Okay, to maximize discussion time, we'll just move right into the next panel. You know pretty much what the issues on the table are, so let me just briefly introduce the panelists and we'll get to it. In the middle, we have Marie-Christine Solly, who's the Exascale Lab Director for Intel. On the far end, John Johnson, Pacific Northwest National Laboratory. And next to me is Satoshi Sakaguchi, who is the Deputy Director General of the Directorate for Information Technology and Electronics at the National Institute of Advanced Industrial Science and Technology in Japan. Thank you all for coming. Welcome to the panel. My seed questions, which you can ignore or honor at your choice, are: what software and tools does data science need? This is, after all, the software and tools panel. How do they differ from what's currently available? What is the impact of unstructured data on software and tools? What about ease of use by non-experts? There I'm thinking, for example, as data gets more interesting to the general public, like, say, your data from Facebook or LinkedIn, people may want to analyze it themselves. They're not experts. They do need tools. And then just in general, what about openness? You know, there are lots of open data movements, and, you know, those maybe have implications for the kind of software and tools that should be available. Anyway, those were my initial thoughts. You're the experts. Perhaps we could have a sort of brief statement from each of you, and then we'll do discussion. Satoshi, would you like to start?
Okay, thank you very much for having me in this panel discussion. And then, well, maybe I received the agendas for the discussion, but well, I'm sorry. So my answer is not directly responding to the questions. So,
great, because this is supposed to be a free-ranging discussion. You can say basically whatever you please.
Right. So, well, from my point of view, that the current the movement happening in the data science, that originally this kind of the data science is from the kind of the big science by the elite scientist. But now it's moving into the so-called citizen science. We need to involve more people, and we need to touch on the kind of long tail the science in the field, so that it's a kind of the data sustainability. So we need more data into this kind of business. So we need to invite more sympathizers of science, so that to make things happen, so that we need a kind of a platform there where that the people can play around by within such a data. So that kind of the tools and the software is necessary for this moment. So that's my short opinion on that.
Thank you. Christine?
Yes, my thought on this actually concerning the tools and the software that is needed to realize this science out of big data is also a bit dictated from the fact that I come originally from the HPC world, but in my career I had a chance to work very closely to a large big data experience, so I learned quite a bit of these two worlds. And now we are seeing that the two are somehow intersecting, or at least they are moving in opposite direction, in the sense that one is getting, as we heard, the sensors want to absorb, for example, more intelligence, more processing close to where the data has been collected. On the other side, there are many of the traditional HPC workloads that need to get more and more interested and to ingest data while we drive this. So this has an impact on the kind of tools and methodologies. And I think this is a tremendous opportunity for developing many things, because to my understanding, we're not there yet. For example, we need tools to be able, as you were mentioning, to be able to put already structure or meaning into the unstructured data. So this is a whole realm in that. And behind this data, there are the users that often don't know what they don't know. So we need really to be very creative there and be able to have the tools that they will be able to use. Second, for example, coming from the HPC side, there is maybe the interest to have, okay, in those very complex data, there might be the possibility at some stage it might be beneficial to actually use a very wide server to make some further analysis. How to make this decision? So we would need tools to be able to identify what part of the data would need specifically that. And as a final first comment, I would say that it's interesting that HPC, actually, as we know, is really striving at making the data move as little as possible, whereas big data is just exactly the opposite. It's about data moving and actually making sure that the processing is made in time, that the next burst is not being perturbed. So I think there are some interesting challenges here.
Thank you. John?
So I would argue that there are no tools for data-intensive science, or virtually no tools. So if you think about data-intensive science, there are sort of five sort of big categories. There's large volumes of data, massive volumes. There's high throughput, that's a different category. There's heterogeneity, so bringing in different types of data and associating different types of data. There's complexity, so when you start trying to do analytics on large data, and your algorithms don't scale well with the data, you introduce complexity, that's another grand challenge. And then the fifth is distribution. So data is distributed worldwide, and there needs to be a way to reach out and collect that data and analyze it. So when you look across those spaces, I think there are individual tools to support analytics in each of those, and then you start pairing them together and combining those, that becomes even a greater challenge. So I think at this point, we don't have the tools, but in terms of this being the sexiest field, that's a great opportunity.
Mm-hmm. Thank you. Actually, this is strange because I think I agree with all of you. And as far as getting the tools, to the extent that data science is going to be something broad, so much broader than just analyzing scientific data, getting and engaging, where we will get a lot of non-experts involved, people who they can pose a question, but they don't necessarily have the tools to get it answered. A lot of other things may be missing as well, but in particular the tools. Where are the tools going to come from? Because for scientific data, we have scientific laboratories, they're funded, they need tools, they'll be budgeted for and created. But if you talk about people who are non-experts, just various people out there in the world who want to analyze data, it's a question of sort of starting a market. It doesn't really seem like there's a marketplace for that stuff now. It needs to be seeded with some sort of software and tools. Maybe eventually the answer is they can buy it. But how is that going to happen? Does anybody have thoughts on that? John?
So I actually do think it'll start in the HPC community, because we actually have more data than the other communities that we have to deal with based on simulation and experiment. So I think the experience of the HPC community is going to be instrumental in being far ahead of the field in terms of understanding how to perform these types of analytics. If you look in the business space, there's growing need, but the tools that exist out there are still workstations tools. There are very few that operate in parallel. There's just a lot of expertise that we have in our HPC community that just has not translated yet into the business community. And so I think over time that may or it necessarily should happen, but I think for now we sort of have to push ahead and be the leaders in building these tools.
Marie-Christine?
Yeah, from my side, I think they will come from the HPC community and from the data, experimental data or observational data community, because they do have also certain challenges and they do have idea how to move forward maybe closer to HPC. So I think the two worlds really will have and already engaging in having these developments by aggregating competences that come both from the side of the scientist that is eventually extracting the knowledge and validating and using the knowledge, computer scientists, mathematicians. Mathematicians are going to play an incredible role in there because we need all sorts of mathematics from topology to statistic, probabilistic, stochastic method. And it's really at the conjunction of that. So I would say from both worlds, but it has to be open, because then it's by best known method and outreach, then it will be taken by maybe smaller communities that would translate it into business.
Satoshi?
Well, again, I'm not answering your question directly, but yeah, well, I'm thinking, I'm thinking that, well, maybe many of you are familiar with the so-called Code for America. So they're in the project, so the people can access to the open data and then create a piece of the software component, and then they put into some public space, and then the people come together and they created a very interesting application for some local government or the federal government. So this kind of the mechanics or model would be the good for, or again, the data scientists, the data science in the community. So the open the data and then the encouraging such a very good the tool developers into that community, then you can collect the such a software pieces. So.
Yeah, I think that's a very interesting idea. I think crowdsourcing is a very valuable thing. I think if data science and HPC merge, or to the extent they merge, those of us in the sort of compute-intensive end of and the high end of HPC might have to rethink who we see as our colleagues. I think sometimes we may not explicitly state it, but we like to think of ourselves as sort of the science elites, and we don't want to deal with the unwashed masses, but they are where a lot of the data is going to come from, and they are where a lot of the interest in analyzing the data is going to reside. So I think the three of you put out several interesting ideas about how to deal with this software and tools problem. And I think on the one hand, opening up science tools is a good thing, but one problem I see there is when we scientists think the tool is finished and easy to use, user-friendly, it may often not be perceived as such by the uninitiated. On the other hand, we may look at crowdsourced code as really kludgy, flaky stuff. So somewhere this has got to meet in the middle. John?
So if you sort of comment on that, I think it'd be odd if we had a tools discussion and the word Hadoop didn't come up when we're talking about data. So I'll throw it out there. I think that you're absolutely right. If you look at things like MapReduce and Hadoop, I think one of the reasons that that's so popular is because it's one of the only tools that's out there for the masses. It's certainly not a perfect tool. It only addresses a very small space of problems. From the HPC community, you can look at challenges of interconnects, challenges of file I/O, and all the challenges that are going to not allow those techniques to scale as they currently exist. But if you look at past supercomputing and past ISC, what you're starting to see is some HPC vendors implementing MapReduce or Hadoop over InfiniBand using MPI. You sort of started seeing some of these things. So I think that you're right that there's a sort of interaction that we have with these other communities where we can bring levels of expertise and say, here's a sort of niche area where you've identified a tool that your community seems to like. We can raise that to another level to solve those problems. But then we can also address that massive other problems that aren't being addressed by that particular technique.
Thank you. I think we have a few minutes left, so anybody have any thoughts whatsoever they would like to express? Go for it. No? Do I? I think we've pretty well covered it, actually. If the problems were only so easy to solve as they are to lay out. Okay. Well, thank you all very much. Audience, please thank the panel.